Hi, in this video we are going to learn how to solve exponential equations. At the end of the video, you should be able to solve exponential equations with the same base and also be able to solve exponential equations with unlike bases. Let's begin. How do you solve exponential equations with the same base? Here is the property of equality for exponential equations. It says that two powers with the same positive base b, where b is not equal to 1, are equal if and only if their exponents are equal. To explain further, if b is greater than 0 and b is not equal to 1, then the equation b raised to x is only equal to b raised to y if and only if x is equal to y. This is the main property we will use to solve exponential equations. The whole idea is we can just take out the same base and write the equation of the exponents, and so we can solve your value of the variable. An exponential equation is an equation whose exponents are having variables. Here is your specific example. So you see, we have a variable on the exponent that makes it an exponential equation. How do you solve? You can just actually take out your 2, cancel them, and so we can now write your equation of the exponent x is equal to 5. What we just did is just actually cancel your base. We can only cancel it if they are the same. Then writing your equation of your exponent x is equal to 5, actually it's already done. To make both sides equal, this x here should be 5. Okay, let's have some more examples. Let's try. You have here your given 3 raised to x plus 1 is equal to 3 raised to 5. How do you solve it? Since the bases are the same, then the exponent must equal to each other. So you just cancel your 3, and that is now the remaining are gonna be your equation. The one that's not cancelled out, which are your exponent, is now written as equation 3x plus 1 is equal to 5. And then you can now solve for your x by subtracting 1 on both sides, minus 1, minus 1, and so you find your x. X is equal to 4. To make the expression both equal, x should be 4. 4 plus 1 is 5. Very easy, right? Let's have another example. So what if there's no exponent? What do? There should be a 1 here. To explain, since the bases are the same, the exponent must equal to each other. Cancel out your same base, and so you can write the equation of the exponents. 1 is equal to 2x minus 3. How do you proceed? Well, you can just add both sides by 3. So that's why you have a 4 minus plus 3 plus 3, and so you got 4. Divide both sides by 2, divide by 2, so you have 2. X is equal to 2. Okay, next you have here base 10 to the power of 3x is equal to 10 to the power of 2x plus 3. The same deal, cancel out your 10. Since the bases are the same, the exponent must equal to each other. Cancel out your 10, and so you have 3x is equal to 2x plus 3. Very easy. You just subtract both sides by 2x, and you actually just found your answer, because of course this becomes 1x, and so it's equal to 3. And it's done. Okay, now let's try some more examples. Let's have your first example. Another example, 2 raised to 2x is equal to 2 raised to 6. Again, you just cancel your 2, take out your 2, and so your equation should be 2x is equal to 6. Divide both sides by 2. Divide by 2. X is equal to 3. Easy, right? Another, you just have here your another example. 5 raised to 2x is equal to 5 raised to x plus 1. You just cancel your 5, and so you have 2x is equal to x plus 1. Subtract both sides by x minus x, and so you found your answer. 2x minus x is x, and then bring down 1, x plus 1. It's that x is equal to 1. That's the value of x to make both sides equal. Here, the last example in your same base, cancel out your 7, and so you write the equation of the exponents. 3x plus 5 is equal to x plus 1. Minus both sides by x minus x minus x. You have 2x is equal to plus 5. 2x plus 5 is equal to 1. Minus 5 minus 5, and so it's negative 4. 2x is equal to negative 4. Divide by 2. Divide by 2. X is negative 2. Okay? It's kind of easy. It will be difficult if the bases are not the same. So, here we are. How do you solve exponential equations with unlike bases? To solve some exponential equations, you must first rewrite each side of the equation using the same base. Example, 5 raised to x is equal to 125. 125 is actually a perfect number. To explain, since the bases are not the same, you can write 125 as some power of 5. So 5 raised to what number is equal to 125? Actually, it's 5 cubed, because 5 squared is 25. It's 5 cubed. So by just rewriting 125 into 5 cubed, we now have the same base. So the deal about unlike bases of exponential equations is that you have to rewrite one value into a power of a base which is the same base with the other. Or the worst is both are supposed to be rewritten to have the same base. But here we are. So we're almost done. You just cancel out your 5, and so you have equation x is equal to 3, and obviously 5 cubed is equal to 125 because x is 3. Let's have another example. So looks familiar now. Which we have unlike bases, 4 and 2. 4 raised to x is equal to 2x minus 3. So this is the one that we need to rewrite. To explain, since the bases are not the same, you can rewrite 4 of some power of 2. So what will be the power of 2 to become 4? Very easy, 2 squared. 2 has a power of 2 to become 4. The 4 becomes 2 squared. 2 squared raised to x means 2 times x. The exponent will be multiplied from the original given exponent. And so you can now clearly take out your bases. And so you have 2x is equal to x minus 3, the equation of the exponents. And so subtract both sides by x. 2x minus x is 1x. And you found your answer. X is negative 3. It's a little tricky, but you remember, have your power table always ready. The number can get worse. Look, 9 raised to x plus 2 is equal to 27 raised to x. There is no way that 27 can be a base of 9. Obviously, the reverse is not possible. Actually, this is the one that I was describing. The worst case scenario is that we need to rewrite both sides into powers of the same base. So to explain, since the base are not the same, you can write 9 and 27 as the power of the same base, power of the same number. What do you think? Looking at your power table, the only base that would work is actually 3. 3 squared is 9. 3 cubed is 27. Then 9 will be replaced by 3 squared and 27 will be replaced by 3 cubed. Here it is. And then you're not done. We cannot cancel it yet. We need to multiply 2 to the power of x plus 2. It becomes 2x plus 4. 3 times x is just 3x. Remember, we need to distribute 2x and then 2 times 2, 4. And then we can now clearly cancel out your 3 bases of 3. After cancelling, you have the equation of the exponents. 2x plus 4 is equal to 3x. What happens? Let's see. To explain, minus 2x minus 2x. 3x minus 2 is 1x, so you found your x. To make the expression equal, x should be equal to 4. You may use your calculator for checking. Let's have some more examples. Look at your power table. Actually, 32 can be written as power of 4. 4 to the power of 5. So the other side, the left side, does not change. 32 is actually 4 to the power of 5. No. Actually 2. No. So here is our first example. 4x is equal to 32. No. So here is your example. Further, another set of example. So here are some more examples. Let's try 4 raised to x is equal to 32 raised to 6. Your power table will be very, very helpful. Let's try. Here are your other examples. More examples. Let's have 4x. 4 raised to x is equal to 32 raised to 6. Look at your power table and see which base works. Base raised to a power works for 4 and 32. Actually, 4 does not have a power of a number and gives you 32. Actually, we are going to rewrite both sides. So actually, 2 raised to 2 is 4. 2 raised to 5 is 32. After rewriting, you multiply 2 times x to x, 5 times 6, 30. And then you can now cancel out your base. You have the equation of the exponents. 2x is equal to 30. Divide both sides by 2 and you found your x. X is 15. That's it. Here, 9 is a special number with a base of 3, so you can rewrite 9 as 3 squared. And then multiply 2 with 2x. You have 4x. Cancel out your base 3. We have now the equation of the exponents. 4x is equal to x minus 6. Subtract both sides by x. You will have 3x is equal to negative 6. Divide both sides by 3. You have x is equal to negative 2. And we found the value of x. Let's have the last example on this page. You have 4 raised to 3x is equal to 8 raised to x plus 1. So it's going to be the same here. 2 cubed is 8. So 2 squared is 4. 2 cubed is 8. We cannot have 4 squared because 4 squared is 16. So it's not possible. So our common base will be 2. So 4 is 2 squared. 8 is 2 cubed. So you multiply 2 times 3 is 6x. 3 times x plus 1 is going to become 3x plus 3. Cancel out your 2 and you have now the equation of your exponents. Subtract both sides by 3, minus 3, cancel minus 3, it becomes 3x. Divide both sides by 3, and so you have now x is equal to 1. And that's it. We have some more complicated cases. Let's try these examples. To solve some exponential equation, you must first rewrite each side of the equation using the same base. This is another case of unlike bases. Look, you have 1/2 raised to x is equal to 4. Since the bases are not the same, can you write 1/2 and 4 as the power of the same number? Actually, yes. Remember, it's going to be power of 2. Remember, if you have a fraction, to rewrite it as a whole number, the exponent can have a negative. We are taking this law backwards. So 1 over a raised to x is going to become a raised to negative x. Therefore, if this is 2, then it's going to become 2 raised to negative x. Therefore, this is going to become 2 raised to negative x is equal to 4. 2 raised to negative 1 or negative x. 4 squared is 2. 4 is equal to 2 squared. Negative 1 times x is negative x. This is the one I'm trying to explain here. It's as a shortcut. So we now have the same base. You just cancel 2, and so your equation is going to become, the equation of exponent is going to become negative x is equal to 2. Divide both sides by negative 1, x should be negative 2. We found your value of exponent, negative 2. 1/2 raised to negative 2 is actually equal to 4. Let's have another example. Here, we will consider the same. If we are going to flip this one, it's going to become 64 raised to negative 1. But actually, 64 is actually 4 raised to negative 3. Since the bases are not the same, you can rewrite 4 and 164 is the same power, which is actually 4, as I said. And 64 is actually 4 raised to 3. And since it's a fraction, to rewrite it as a whole base with a negative exponent, negative 3. So we have 1 over 64 is 4 raised to negative 3. And so we now have the same base, although the exponent is negative, it does not matter. We can now cancel your 4. Your equation of exponent is x plus 1 is equal to negative 3. Subtract both sides by 1, this becomes negative 4. And we found your x is equal to negative 4. And it's going to be the last example. Remember your rule. If we are going to flip this one, 3 will be raised to a negative 1. 27 has a base of 3, so we can have the same base. So here it is. Your rule, it follows this rule. 1/3 raised to x is going to be the number raised to negative exponent. Since there's no exponent, it means 1. 27 is actually 3 cubed. So negative 1 will be multiplied to the x negative 1. So it becomes negative x plus 1. And now we can now clearly cancel 3. Take out 3 and we have the equation of the exponents. Negative x plus 1 is equal to 3. Minus 1 on both sides. 3 will become 2. Divide both sides by negative 1. X is positive. X is negative 2. Okay? And that's it. We're done. As a review, how to solve exponential equations with the same base. This is the easy one. If the bases are already the same, the exponent must be equal. Or you just simply write the equation of the exponents. Then solve for x. How to solve exponential equations with unlike bases. Well, this is the harder one. If the bases are not the same, you have to think what number raised to a power will equal the original base. And then you want to have both bases changed to the same base, then the exponents must equal. After having the same base, you just take out your base and write the equation of the exponents and solve for x. Okay, you can watch this video again if you need to review. Thank you.